Hello, in this video I will go over more in depth of the unit circle and introduce the six trigonometric functions and how to find the sixth trigonometric function when given an angle or theta. So yeah, in this section I will go more in depth of the unit circle. I will introduce the six trigonometric functions and how it coincides with the unit circle. So I would strongly recommend downloading a unit circle. I think I should have a unit circle on the downloads. You can download from there or just find one on the internet. It's fine. Okay, so let's talk about the unit circle. So this is your unit circle. I would always have one in handy when doing trig. So yeah, go ahead and print one out. Just like the Cartesian plane, the unit circle has quadrants and coordinates, right? So it's very similar to the Cartesian plane. Like if you graphed a linear, you know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and then this is quadrant 4. So yeah, you have coordinates as well. So if you look at the 30 degrees, 30 degrees is also the same thing as pi over 6. And you'll see that you have a coordinate or an x coordinate of radical 3 over 2 and a y coordinate of 1/2. Okay, so there's a reason why why that is. They didn't just make it up. We'll go over that in another video where I will talk about 30, 40, 60 triangles and how it had these, how it got these coordinates. There's a reason. Okay. So yeah, you have coordinates. You also have degrees and radians. So in the previous video, we did talk about how to convert degrees to radians or radians to degrees. So for example, 30 degrees is the same thing as pi over 6. Okay. There's no real trick in memorizing the unit circle. Yeah, sadly, I don't know any other trick. I only recommend knowing or memorizing the 30, 40, 60, 90 and its coordinates since the unit circle is pretty much redundant. So yeah, I would focus on quadrant 1, the 30, 40, 60, 90, and look at the coordinates. So on 30 degrees, it has an x coordinate of radical 3 over 2 and a y coordinate of 1/2. The 45 degrees has an x coordinate of radical 2, comma, radical 2. I mean, a y coordinate of radical 2 over 2. This is easy to remember that it's the same. And then 60 degrees, it's pretty much the reciprocal of 30 degrees. It now has an x coordinate of 1/2 and a y coordinate of radical 3 over 2. So what do I mean by redundant? So if you look at quadrant 2, see how the coordinates are the same. It's just the only difference is the x coordinate is negative and the y coordinate is positive. So if you look at, for example, if you look at 150 degrees or 5 pi over 6, it is related to pi over 6 because they're the parent family. So that's a big clue how you can memorize it. 5 pi over 6 is related to pi over 6 because they both have that 6 on the bottom. And as you can see, they're exactly the same coordinate. It's just that x is negative. The same thing with 135 or 3 pi over 4. It is related to 45 or pi over 4 because they have that 4 on the bottom. As you can see, it's the same, just the x is negative. And the same thing with 120. Same coordinates, x is negative. Okay. And then if you look at quadrant 3, same thing. The only difference is the x is negative and the y is also negative. So 210 is related to, or 210 or 7 pi over 6 is related to pi over 6. It's just that the x and y are negative. That's pretty much it. See how it's redundant? If you look at quadrant 4, 300, what is the difference? The y is, the x is positive, but the y is negative. So if you look, for example, at 300 degrees or 5 pi over 3, it is related to the parent family, parent pi over 3. It's just that the y is negative. So yeah, there's no trick. yeah, you just have to memorize it. If you remember the 30, 40, 60, you'll be fine. You just got to figure out which quadrant you're in. Quadrant 1, cosine is positive, sine is positive. Quadrant 2, the cosine is negative and the sine is positive. Quadrant 3, the cosine or the x is negative and then the y is negative. And in quadrant 4, the x is positive and the y or the sine is negative. So yeah, there will be another video of the 30, 40, 60 triangle. Okay, memorize it really well. Now we can find the 6 trigonometric functions. So what are the 6 trigonometric functions? So here are the 6 trigonometric functions. You have sine, cosine, and tangent, secant, cosecant, and cotangent. I strongly recommend is knowing the first threes, sine, cosine, tangent, because secant or 4, 5, 6, secant, cosecant, cotangent are pretty much the reciprocal. Secant is abbreviated as CSC, and the clue is that it is the reciprocal of cosine because it has a C. Cosecant is abbreviated as CSC, and the trick is there is an S in the middle, so that's how you know it's related to sine, so it's the reciprocal sine. And then cotan or COT is related to tangent, which literally means reciprocal of tangent because it has that little t. So that's a little trick I remember. Okay, so no 3, sine, cosine, tangent, and then the rest are just the reciprocal. Okay, let's do some. Let's see. Oh wait. So this is more in depth of what so how do you find the 6 trigonometric functions? So how do you find the sine, sine, cosine, tangent, cotan, secant, cosecant, etc.? So you can use SOHCAHTOA and its reciprocal if it's a right triangle, right? I think we went over that on another video. So if it's a right triangle, you could do SOHCAHTOA. You can also do so cosine is the same thing as adjacent over hypot. Or you could also think of it as x over radius. We'll go what that mean when we'll do some word problems and you'll see that the radius is the same thing as the hypotenuse. Okay, sine could be expressed as opposite over hypotenuse or y over radius. Tangent can be expressed as opposite over adjacent or y over x. Cotan is the reciprocal of tangent, so it could be expressed as adjacent over opposite, or the reciprocal of tan, which is the same thing as x over y. And then cosecant is could be expressed as hypotenuse over opposite, because it is the reciprocal of sine, right? Or radius over y. They all sound confusing, but you'll see when we do an example. And then secant can be expressed as hypotenuse over adjacent or r over x. So also another key factor is if your angle is within the unit circle, like for example, 30, 150, 300 degrees, etc. The x coordinate is the cosine and the y coordinate is the sine, and then the tangent is y over x. So if it is a degree in your unit circle, for example, 30 degrees is an exact degree in your unit circle. And then you'll see in the unit circle, it has these coordinates, right? So 30 degree has an x coordinate of radical 3 over 2, and it has a y-coordinate of 1/2. Now, this is actually easier. They say that if it's a degree within the unit circle, you don't have to do that SOHCAHTOA stuff. What you could do is you could say that cosine is the x-coordinate. So in our case, cosine would be radical 3 over 2, okay? And then sine is the y-coordinate, which is 1/2. And then tangent is y over x. So it's 1/2 over radical 3 over 2, right? And then you can find the rest by flipping it around. Okay, so that's pretty cool. If it's a degree in your unit circle, cosine is x, the sine is the y coordinate. Okay, take a minute to absorb all that. It's a lot. Okay, let's move on. Now let's actually start doing some example problems. So let's start with example 1. If theta, or your whatever you call it, your degree, is 120 degrees, which quadrant does it lie on? And is the tangent of 120 degrees positive or negative? Okay, so first I would get out my unit circle, or if you have it memorized, that's better. First, locate 120 degrees in the unit circle. So 120 degrees is about right here, right? Here's 120 degrees. It is a degree within the unit circle. So it has a coordinate of negative 1/2, or an x coordinate of negative 1/2, and a y coordinate of radical 3 over 2, right? Okay. So which quadrant, let's answer the first part. Which quadrant does it lie on? 120 degrees is right here, so that is technically in quadrant 2. Okay, then the second part of the question says, is tangent of 120 degrees positive or negative? Let's just figure out what it is. So since it is a degree within the unit circle, you don't have to do that SOHCAHTOA thing, right? So what you can do instead, tangent of 120 degrees, this is how you would write it. It's tan of whatever your degree is. Since it is a degree within the unit circle, you could just say it as y over x, right? So what is our y coordinate? What is our y coordinate of 120? It is radical 3 over 2, right? Divided by, what is your x coordinate? It is a negative 1/2. So this simplifies as, this is a complex fraction, so you can multiply both sides by 2. So this would be radical 3, and then 2 times negative 1/2 is negative 1. So I did the little shortcut, the complex fraction thing, which is negative radical 3. If you don't know what that is, just you can rewrite this as radical 3 over 2 divided by negative 1/2, and then cross multiply. That'll give you the same answer. This would be 2 radical 3, and then 2 times negative 1 is negative 2. This cancels. You're left with negative radical 3. Okay, so they didn't actually want you to find it. They just want you to figure tell if it's positive or negative. Our final output is negative radical 3, so it is negative. Okay, so it's negative and it lies in quadrant 2. Okay, go ahead and take a minute to absorb or write down everything. Okay, let's move on. Okay, number 2, or example 2 says find the sixth trigonometric function when your theta is 60 degrees or your angle is 60. So 60 is within our unit circle. So first, I would do is kind of draw a little image if you have to. First, locate where 60 degrees is in the unit circle. So 60 degrees is right here. And it has an x-coordinate of 1/2 and a y-coordinate of radical 3/2, right? This is your x, this is your y. But we got to find the sixth trigonometric. So what do I mean? So they're asking the sine of 60, cosine of 60, tan of 60, this secant is 60, the cosecant of 60 degrees, and then the cotan. Okay, so I would just do the first three, and then the other three are easy because you use just the reciprocal. So how do we find sine of 60? Since it is an angle within your unit circle, you don't have to do the SOHCAHTOA thing. Okay. If it makes, yeah, you don't have to do that. Instead, we could do something more easier, right? The sine is the y, and then the cosine is the x. So what is the sine of 60, or what is the y coordinate of 60 degrees? So if you look at here, we have a y coordinate of positive radical 3/2. Okay. What is the cosine of 60, or what is the x coordinate? It is positive 1/2. Now, tangent, you can express it as, you don't have to do the opposite of adjacent. It's just y over x. I just want to really quickly explain, like, what do I mean by SOHCAHTOA? So if you try to do it that pathway, you can, but you'll have to kind of draw an image. So this is a 60 degrees, and then draw like little triangles. This is like a 90, and then this angle here has to be 30. Yeah, and then you would have to find the sine, cosine, etc. But I haven't gone over the 30, 60 more in depth. So yeah, let me go over the 30, 60, 90, and then you'll see why this is 1/2 radical 3/2. Okay, so for right now, we could just do the what we're doing right now. So tangent of 60 is the same thing as y over x. So our y coordinate is radical 3/2, and my x coordinate is 1/2. This is a complex fraction, so this 2's cancel, so you're just left with radical 3/1. Okay, let me box these so don't get confused. Okay, now secant, the clue is there's a c here, so that we know that it's just the reciprocal of cosine. So if your cosine is 1/2, what's the reciprocal of that? 2/1, or just 2, right? Cosecant of 60, so the clue is there's an s in the middle, so it's just the reciprocal of sine. So what is our sine? It is radical 3/2, so we just have to flip it, the numerator and denominator, so that would be 2 radical 3. Now, I don't like having a radical on the bottom. Usually your teacher don't like that. They don't want a radical on the bottom, so you have to rationalize the denominator by multiplying top and bottom by radical 3, right? So this is going to be 2 radical 3, and then on the bottom, radical 3 times radical 3 is just 3. So that's 2 radical 3 over 3. And then cotan 60. The clue is the reciprocal of tangent. So what is the reciprocal of tangent? This is like the same thing as radical 3 over 1. So the reciprocal of that would be 1 over radical 3. And you can't have a radical in the bottom, so rationalize it by multiplying top and bottom by radical 3. Okay, so this is going to be radical 3, and then on the bottom, this is just going to be 3. And that's how you find the six trigonometric function of angle 60, or when theta is 60 degrees. Okay, go ahead and take some time to absorb. It is a lot of information. Okay, let's do one more example, then we'll finish the other in another video. So example 3 says, name all the quadrants in the unit circle where tangent is negative. Okay, so they just where tangent is negative. So let's see. So here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So what is tangent? If it's within the unit circle, tangent can be expressed as y over x. So in quadrant 1, the x coordinate is positive, and then the y coordinate is also positive. In quadrant 2, the x coordinate is negative, and the sign is positive. In quadrant 3, the sign is negative, and then the cosine is negative, and the sign is negative. And in quadrant 4, let's see, the cosine or the x is positive, and the y is negative. So let's look at quadrant 1. What is tangent? It's y over x, right? So your y is positive and your x is also positive. That gives you an output of positive. So quadrant 1 works. What about quadrant 2? The y is positive and the x is negative. So that gives you an output of negative. We can't, oh, they're asking which one's negative. So quadrant 1 won't work. So quadrant 2 works. What about quadrant 3? The x is negative and the y is negative. So that's like saying negative over a negative, which is technically positive. So that's not going to work. What about quadrant 4? The x is positive, the y is negative, so that is negative over a positive, which, if you recall, that is going to be a negative. So quadrant 2 and quadrant 4 are the only ones that gives you a tangent of negative. Okay, yes, we will stop here and we will finish the others in another video.